Good morning, everyone. So today's title of my talk is Disease Management Options for Tomatoes and Pepper. So in my talk, I'm going to talk about some of the unique symptoms we've been seeing lately in peppers and tomatoes in the greenhouse and also in the field. What were the causal agents and how we characterize them and what it means to our growers. That's the first part of the topic. Second half, I'll talk about the management options, especially the fungicide and the chemical management options for important fungal diseases, including septoria leaf spots, and also southern blight, and so forth. And then, in the meantime, I'll also be talking about the copper-based programs, actigide-based programs, and leaf-based programs in situations where we have a tolerance we have a copper tolerance in bacterial spot in peppers and tomatoes, and how the growers have to make decisions based on the scenario which they have. So with this, I would start with some of the important diseases, especially in seedlings we see in both peppers and tomatoes in the greenhouses. So sometimes we see seedling damping off. The seedling damping off can be caused by rhizoctonia. The only difference with that is that the rhizoctonia will cause a pinch at the base of the stem, but that particular pinch would be dry. You will not see any water-soaked lesions in those. They are very easy to diagnose and so forth. This particular tray of tomato was infected with rhizoctonia that came to our disease clinic. Okay, apart from rhizoctonia, we do have another causal agent, which is not a true fungi like rhizoctonia. It's a oomycetes or a water mold. It will also cause pinching of the stem, but the only difference would be it will be more watery or water soaked. Okay. Okay, with respect to leaf spots, a variety of leaf spots we see in peppers and tomatoes. We start with bacterial leaf spot. Bacterial leaf spot can be caused by a variety of Xanthomonas species complexes. It can also be caused by Pseudomonas. We'll talk later about it. We also have a target spot, very well diagnosed. You can see nice target spots. These target-like symptoms over here, they're much more bigger. Then we also have a septoria leaf spots. These septoria leaf spots are quite endemic to Georgia. Whenever we get tomatoes in certain season, especially in late summer or early fall, we see septoria leaf spot. Okay, with respect to bacterial diseases, there's one bacterial disease which can be a mimic of others. One is much more problematic than others. Luckily, we don't see this particular disease every year. It's called bacterial speck. Causal agent is Pseudomonas syringae pathoid tomato. It is quite quarantine pathogen, very difficult to manage. But there's one more symptom mimic of this particular pathogen is called bacterial leaf spot. Bacterial leaf spot will have similar spots as a speck, but it is not quarantined and it is not a big problem. It's, you say, kind of a cosmetic disease, but in certain situation when the plants are stressed, it can cause problem. So the analogy which I have gave, one is a smallpox versus one is acne. So there's a difference. All right, another unique situations we faced. So this particular tray was brought, Ty Torrance brought this particular tray of peppers in 2022 fall, and if you're looking at the spots, it seems like there's a kind of a burn, or sometimes could be some fungal. We never expected it to be. This is a close-up image, but it ended up being stem phyllium. Okay, so this is some stem phyllium spot. Some stem phyllium has a broad host range. Some stem phyllium can jump on crops which are stressed, but those seedlings were not stressed. Okay, well, what we did when we also isolated those stem phylliums and we tested their pathogenicity on peppers, and they were quite aggressive on peppers. So it was one of the unique situations. Okay, another unique situation. Without this title, you would not have predicted that this is a bacterial pathogen. This symptom was caused by bacterial pathogen. Okay, usually we have been trained that bacterial pathogens would follow the veins, and you'll see water-soaked lesions around the veins, or you'll see V-shaped lesions around the margin. But look at this particular lesion. Looks like a target spot on pepper. But we ended up characterizing and naming this pathogen as Pseudomonas capsicii. Okay, if I say P. capsicii, do not be confused with Phytophthora capsicii. It's a Pseudomonas capsicii, quite aggressive pathogen. Okay? And look at the symptoms it caused on the seedlings of pepper. It looks like a fungal disease, but it's not. Okay, don't worry about this chart, but one thing which I want to mention here, this is a whole genome sequencing and core genome phylogeny of Pseudomonas capsicum. And we looked at all these strains in the gene bank and also the strains in Florida that were characterized as Pseudomonas cichoroi. Okay? When we characterized those, we found most of those cichoroi were actually capsicum. So capsicum was actually first identified in Florida in 2012, and they did not know it's capsicum. They named it as a Pseudomonas cichoroi. But later in 2019, 2020, and 2021, we found this disease in peppers and tomatoes, both in the greenhouse and also in the field. Okay. Now, one thing you would notice, this particular pathogen goes to a bunch of different crops. Look at the crops we have. Lettuce, Chinese cabbage, coffee, tomatoes, soybean, what else? Chrysanthemum, tobacco, cabbage, and so forth. It's a quite wide host range pathogen. So what we did a host range test, and since I am more interested in vegetables, I look at the range of vegetable crops. So I looked at pepper, tomatoes, Chinese cabbage, broccoli, lettuce, and endive. Why endive? Because Pseudomonas cichoroi was first identified and characterized from endive. That's why we use endive as one of the checks. So this particular P. capsicum, which we isolated from peppers, had a typical fungal symptoms, but they were not fungi. They are pathogenic on pepper, tomatoes, Chinese cabbage, and lettuce. It's a broad range. And look at the number of strains we used, and including some of the strains from the culture collections. So what does it mean? That this particular species, although we are lucky it doesn't occur every year, but it has a broad host range, it can mess up the rotation, okay, of crops which you use. All right, switching gears. We're going to, next 4 slides, I'm going to talk about our copper-based management in scenarios where we have a copper tolerance against Bacillus spot. Now here, Bacillus spot in tomatoes and pepper, I meant to say that these are caused by Xanthonas species complex, not by Pseudomonas. Because Xanthonas is the one which is quite prevalent. We see it every year. So this is first situation in Bacillus spot in tomatoes. And the scenario is you don't have copper tolerance in this scenario. You have a copper sensitive isolates. Okay? You have a copper sensitivity in your field. So what are the options? So we looked at co-site-based program, co-site and manzate, tank mix. Then we used badge, which is again copper oxychloride with a manzate. And we also used, in a third program, we used oxidate, and then co-site and manzate rotation, and then oxidate, badge, and manzate, and so forth. Now, why oxidate? There's some growers who had more interest in using oxidate. I'm not a big fan of oxidate because oxidase is general sanitizer. If you put on oxidate, sometimes it works, sometimes it doesn't. It will end up cleaning the entire plant, but will also kill all the beneficials. So if all the beneficials are gone, let's say, God forbid, if the primary pathogen jumps on, there won't be any competition because all the beneficials are gone. So that's why I'm not a big fan of oxidate, but oxidate time and again have shown some level of efficacy. But anyway, in this scenario, all this program worked. So if you spray copper and manzate together, more likely it's going to work. Okay. Most of our growers rely on Actigard early on, then do copper and manzate program, and then switch to LEAP later on. Okay, another scenario. In this scenario, you have a copper tolerance. So your Xanthomonas, your Xanthomonas species complex are tolerant to copper. If you spray copper, it may not work. So what are our options? Here we looked at double nickel, which is a softer product. We looked at LiveGuard, another soft product. These are the two number soft products, which I'm not going to talk about. And then I used copper and manzate as my commercial check. So more likely in this situation, copper and manzate did help, but look at the softer products. The softer products have some level of efficacy, not a great level of efficacy, but compared to non-treated check, it did okay. All right, switching to peppers. In peppers, again, first scenario, you have a copper sensitive isolates. So the copper works in this scenario. Again, same deal. We saw any program that has copper and manzate works. Again, you have to start with Actigard, and then go with copper and manzate program in between, and then you can switch to Leap. Okay, last scenario, let's say, and it is quite rampant. In peppers, we do have a lot of copper tolerance compared to tomatoes. In this situation, we looked at all these software products. All the software products do work, but one that stood out in Bechtel spot and pepper was LiveGuard. LiveGuard has significantly lower AUDPC value compared to all the other software products. Okay. So the program which we are recommending for situations where you do have a copper tolerance, you start with Actigard, and then you first 2 or 3 shots, then come back with LiveGuard, and rotate with Leap. So you start with Actigard, do LiveGuard or any other listed software products, and then end with Leap. Okay, so now I'm switching gears. So I'm going to talk a little bit, I'm going to spend some time on pepper, anthracnose and pepper. The reason being, since 2017, 2018, we are seeing increasing trend of this particular pathogen. So there are 2 types of anthracnose. One is primary anthracnose, another is secondary anthracnose. You see secondary anthracnose is always initiated after sunburn. Whenever you have a sunburn, you will see anthracnose. Okay? In that case, the primary pathogen is actually a weaker pathogen. It can only jump on the stressed sunburned fruit. Okay, but there's another anthracnose called primary anthracnose. It doesn't need any sunburn. Okay, it can jump on by its own potential, and it can cause symptoms on fruits. So 2 types of anthracnose. Do we recommend spray for secondary anthracnose? No, because those are weaker pathogen. As long as you protect your crop from sunburn, you'll be fine. For primary anthracnose, of course. So data which I'm going to show now is for primary anthracnose. So before we go into that, I'm going to show you some of the anthracnose work which we did and the type of anthracnose symptoms we see in different peppers. So this is symptom of anthracnose in bell pepper. Have you ever seen such a bad symptomatic anthracnose fruit? This is the worst thing which I have seen. And then we have a cubanal pepper. In cubanal pepper, again, you have the similar symptoms, this nice concentrated to sunken spots, and if you look under the microscope, you will see setae or hairy structure. This is on jalapeno pepper. Okay, we did a survey in 3 or 4 counties. We wanted to see what are the causal agents of these anthracnose, why there is a resurgence of this particular pathogen complex recently. So we surveyed close 3 to 4 counties. We collected close to 135 isolates. We purified those isolates, made a single spore cultures, and then we did the characterization of those isolates. So we found that in bell peppers, there are 2 main Colototricum species. One is Colototricum gliosporidis, another is Colototricum acutatum. This is how acutatum would look, and this is how gliosporidis would look. Very difficult to distinguish unless you are a mycologist or a trained eye. You cannot distinguish under the microscope. So we have to rely on some molecular methods too. Now, in cubanal peppers, it was mainly the main pathogen which we recovered was Colototricum acutatum, not gliosporidis. Okay, and in jalapeno, the things were a little different in jalapeno. In jalapeno, we found another species, Colototricum truncatum. This is how truncatum would look. But we also found some gliosporidis and acutatum. But this is the only species where truncatum was found. So if you look at the truncatum spores, they look like a fusarium spores, Christian-shaped structure. So if you are not experienced enough, you'll be misdiagnosing this particular pathogen or particular symptoms with fusarium. But these are not fusarium. These are Colototricum truncatum. Even Colototricum capsicii, there's another species, will also have this kind of spores. Moving on, I do not know how good you see, but we did the fungicide sensitivity assays on Colototricum truncatum, gliosporidis, acutatum, and so forth. But we found that these guys have a higher EC50 values. Not all isolates, but the majority of the isolates have high EC50 values. What does it mean? It means your isolates are less sensitive to azoxystrobin. So, but not all isolates. Okay, this is in particular in jalapeno pepper. This particular isolate was had a very high EC50 values at 10 ppm. Okay, and this I don't know. You can see this is spore germination assay where we amended this particular media with 10 ppm of azoxystrobin, and we can see the spores of Cortaticum truncatum could grow. So that means it has and it shows, when you look at the AC50 values, it is much higher. So there is a trend that most of the isolates might be moving towards becoming insensitive to azoxystrobin. Okay, this is the gist of all the functional sensitivity assay. You can see this block of those isolates from Cubanel and Bell papers. They do have a high EC50 values, indicating they will be less sensitive to azoxystrobin. But we do have some isolates with the lowest EC50 values. In this scenario, azoxystrobin may work. Okay, so this particular trial was done in 2022 in Grady County. We looked at different products. We looked at TopGuard, Mirwis Prime Switch Inspire Super Quadris, Approvia Top, and Bravo. In this case, Quadris did work. Quadris had a significantly lower fruit rot compared to your non-treated check, but things that worked really well was Approvia Top. Approvia Top was one of the best performer in this particular trial. And Bravo by itself also has a good level of efficacy. So if you use these products in rotation with the Bravo or tank mixing with Bravo, you're doing a good job. So again, I'm reiterating, these are all for, these fungicide trials were done on primary anthracnose, not secondary anthracnose. Secondary anthracnose, you have to protect your fruit from getting sunburn. Okay, switching gears, going to septorial leaf spot. Septorial leaf spot is another endemic disease. We see it every year. Sometimes it's much worse in fields that were not, where fungicide programs had not been initiated on time. So in this septorial leaf spot, you can see these nice septorial leaf spot lesions on the leaf, on tomato. So I looked at some of the products like Luna Flex, Luna Tranquility, Inspire Super, and TopGuard. I just wanted to see the individual efficacy of these premixed fungicides. And 4 shots, 10 days apart. All of them did well. This is AUDPC value. This is total disease in a season. All of them did well compared to the non-treated check. So you can use, all of these are actually labeled on tomatoes. So you can use these in rotation and of course have a Bravo in between. That's the good news. Okay, there's something new I want to talk about. It is southern blight. Southern blight in tomatoes, again, it's a soil-borne pathogen. There are certain fields in Georgia that already has a history of a southern blight. And if you do if you have a watermelon and peanut rotation, and if you have this particular pathogen in your peanut, it may cause a problem in tomatoes too. So the things which we looked at, rime is labeled as a drip application for southern blight. Not for the southern blight, but drip application for other diseases except southern blight. So we looked at the rime, and what you're looking at is final disease incidence, and this is a non-treated check. So close to 87% of our plants were already been infected with southern blight. But when we applied rime 3 times, 2 weeks apart, through drip, we saw a significant reduction. Okay, what else? Rime via drench was one of the best, but it's not labeled for drench use. I just want to show that in this case, rime also worked as a drench application at a very high rate. Low rate, at a 5-ounce rate, it will do also have some activity, but at a higher rate, it worked very well. Okay, what else? TopGuard EQ. TopGuard EQ is labeled, but not for southern blight. It's labeled for other foliar diseases. But in this case, TopGuard EQ is also not labeled for soil use. But in this particular trial, we applied TopGuard EQ by modifying the nozzle, attacking or not modifying the nozzle, applying at the base of the plant. Okay, so there's a directed spray, Quadris directed spray, which is again not labeled, but it did have some effect, good bit of effect. And then Fontellis, which is our grower standard. Soil use Funtalis either use via, either you can use as a drench or use a drip. Most of our tomato growers are on drip. So if you use it through drip and put good bit of water, you will have a decent efficacy. But again, I'm afraid with Fontalis because we rely on Fontalis a lot on southern blight. So I would recommend that that rime can be used, which is a label used for soil use. But the only thing is that southern blight is not in their spectrum because they did not know about it until a couple of trials we did. So rime soil label is better, is quite beneficial for our tomato growers in situations when we have a southern blight issue. So we can rotate rime and Fontalis. I think this is what I have. So questions on either bacterial spots or any new symptoms and new diseases, anthracnose or southern blight, I'll be happy to answer. Yes. I don't have a data on anthracnose in tomatoes. And neither we do not see anthracnose in tomatoes a lot rather than peppers. Do you see anthracnose in tomatoes in your region? Mm-hmm. Okay. East Tennessee. Okay, we don't. Tim, you might be better to answer this one. Do we see anthracnose in pepper and tomatoes here in Georgia? Sure. So we did 3 applications. The first application was made 3 weeks after planting, 2 to 3 weeks after planting. Thank you. All right. Thanks.
Thank you, Dr. Babesh. Next, we have Dr. Sadiq Bag. He's a virologist with the University of Georgia.
Good morning. So I will switch gear a little bit and we'll talk about viruses. So viruses on tomato. So this, before we proceed, this is a work that is done in collaboration with, the work is all done by my postdoc, Manish, who is here, and then Ty and Kale, who is in Grady County, and Tifton, Colquitt, and Worth County, and Dr. Ted McAvoy, who is vegetable researcher, and we have one collaborator from UF, Dr. Samuel Hitton. And this project is funded by Georgia Vegetable Commission as well as collaboration with the USDA, ARS, and UGA. So we know all about, we have the tomato production here, and this is the data from 2021, and what we have is about 8.9 million of farm gate value for the tomatoes in Georgia. So in this case, we are seeing that all the tomato production what we have, they have different virus issue, and one of the most important one is tomato yellow leaf curl virus. This virus is transmitted by whitefly, and this is one that we see a healthy tomato, and this is one what we see as an infected tomato. And this is widespread across the world, and there are different management strategies. But the most important or the effective management strategy is either using host resistance or having a resistant cultivar that we use in our cultivation, or try to avoid whitefly. So all the cultivar that are commercially available at this point, they are having intermediate resistance against tomato yellow leaf curl Israel isolate. Israel isolate is more prevalent in our region. Okay, so all the commercial varieties or cultivar we are growing, they have intermediate resistance. When I say intermediate resistance means they will have some level of tolerance, but they will show some symptoms. They are expected to show some symptoms and have a level of tolerance. What we are trying to see that over a period of last 4 or 5 years since I'm here, we are seeing more and more disease incidence or TYLCV disease incidence on tomato. So we looked into what is happening there. So what we are finding that there is one more new virus that is introduced or that is present in tomato, that is tomato chlorosis virus. This was first found in 2011, and since then not much work is done in this one. Every work or everything is related to TYLCV. So how both are different? So this is a tomato field. What we are seeing is in the Grady County. So see how it is infected with the TYLCV, and we see the symptoms. All the plants are dwarf, and this is a typical symptoms what we found in our experimental plot in UGA Tifton campus. And this is a symptom what we usually see with respect to tomato yellow leaf curl virus. The leaf on the top are curling with the yellow border at the edge, so at the margin. So this is TYLCV symptom. Now look at the TOCV symptom. So when we went to the field, I was told that these all symptoms what we are seeing here, they are nutritional. So the virus mimic the symptoms that are nutritional deficiency. In this case, it is magnesium deficiency. So if there is a magnesium deficiency, the symptoms looks like this, where we have symptoms here in the leaves, or the leaves are folding, they are more turgid. At the same time, these symptoms could be due to the heat that is coming out from the reflective index, mulches. But all these symptoms are associated with the virus. This virus is also transmitted by the same whitefly. So same whitefly is transmitting both the viruses. So this is what we see on the top of the TYLCV infected plant, on the upper foliage, and what we see TOCV, it's mainly on the lower foliage. The symptoms are that much differentiated, but the virus is present throughout the plant. So we looked into different commercial varieties. As I said, most of the commercial varieties are having one or other host gene resistance. So far for TYLCV, there is TY1 to TY6. There are 6 different genes that are identified. And most of the commercial varieties what we use, they have either combination of TY3 or TY6 or TY1. And for Czech, we have this one, Varietal and Seabrook. They do not have any resistance gene. So we looked at this, we planted 10 plants, and it's replicated in each plot, and we tested it in Tift County, Grady County, and Colquitt County. So we did the disease incidence, how it is progressing every 15 days, and the virus was tested on 30, 45, and 60 days after transplanting. So what I'm presenting here is just for the Tift County. I'm not presenting for the Grady and Colquitt County. In Tift County, what we observed is we have much more higher disease incidence compared to the other. But what we see in Tift County is that the first disease appearance is around 15 days post-transplant, and by 60 days, all 100% plant are showing symptoms. Whether it is having a single gene, or it is having 2 genes, or it is having a susceptible Czech, all are showing 100% disease incidence by the 60 days. Whereas in case of Colquitt County, we observed only in 45 days, and in Grady County, we first symptom were observed in 30 days. But by the end of 75 days, in those 2 counties, most of them are showing symptoms. So we looked into the presence of the virus in this plant, and in this case, what we are seeing in the 45 days and 60 days for TYLCV, we see they are present in almost all, and in Varietal that is not having any resistance gene, that is having more virus compared to the other. And when it comes to the other one, TOCV, what we are seeing that here we have Grand Marshal or others, almost all are having a very high level of virus accumulation. So virus is present in both the combinations and in all the 3 counties. Further, what we have seen, as I said, for TOCV, only we have first report, that is in 2011. So we wanted to see what, if there is any difference is there. So we are seeing that TOCV, the complete sequence we generated, and we do not see any difference that is present in US versus other part of the world. So what we learned so far in this study is that the disease pressure in Tift County is comparatively higher than what we have in Colquitt or the Grady County. The symptoms are more severe in Tift County. In Tift County, we are getting in 50 days, whereas in Grady and Colquitt is 30 and 45 days, and by 60 days, all the varieties are showing symptoms. When we check against the myrtle, that is the susceptible check, we are also getting the symptoms. And then the virus titer is much higher over there. Whether it is having TY1 or TY3 plus TY6, it doesn't make any difference at this point. So all the intermediate resistance, what we have the cultivar, they are still showing high level of disease incidence. TOCV was first observed in 2011, and now it is widespread in Georgia, and it's also reported from other part of US. Co-infection. So, based on this study and some other study recently reported in 2020, what we suggest that presence of TOCV is helping the virus to break down the host resistance, whether it is TY1. So the other studies that were reported, they say that the TY1 resistance is breakdown due to the presence of TOCV and TYLCV together. At this point, we do not have any host resistance against TOCV. So further studies, what we are doing at this point in our lab is to study for TY3, TY6, or TY5, or other TY genes what we have, and try to study which one will have a better resistance against the combination of this virus. So this is what we have learned in last 1 year, and further studies is needed. So if we want to know more about that, this is the paper that we have, and it is freely available in the internet, so you can get more detailed study for this one. And we have a poster outside, and if you can catch Manish, and he will be able to explain in more detail in this according to the study. I will switch gear a little bit here. TY, what is there? The other important virus on tomato is tomato spotted wilt virus or spotted wilt. And this is tospovirus that is transmitted by thrips. So we do have a resistance against spotted wilt on tomato as well as on pepper, but we are seeing resistance break in California, Texas, Florida, North Carolina. So far in Georgia, we are not able to see any resistance break. We do see occasional tomato plants that are showing symptoms for TSWV, but based on our study, we are not seeing any resistance break in tomato as far as Georgia is concerned. Another important work recently in this fall, what we see is on tomatillo. Most of the tomato growers, they may have tomatillo in their field. So this symptoms is observed in tomatillo, and this is again very much similar to the nutritional deficiency. And we observed this in Tifton as well as in Grady County. So what we found that these are all due to the presence of the new virus TOCV, not due to a nutritional deficiency. So the virus is now expanding its host range. So from tomatillo to tomato to tomatillo. So this is, we need to do further studies. This is just this fall what we have observed. Finally, if any one of you were not here yesterday, I would like to introduce you to a group. What we are having here is emerging viruses in cucurbits. So this is a group in the nationwide what we have formed, and that's from California to Florida to Georgia and all. And what we have here, a booth here in the second booth as we go out, and we have lot of hands out. Some of the handouts are also in the back of this room. Those are on the cucurbits. And what are the viruses on cucurbits? They are handouts, postcard that give information on the symptom, how to do the testing, how to do a management. So if possible, please visit that booth or grab a postcard if you are interested in, and we would be happy to answer anything in that one. And with this, I would like to thank everyone for joining. And if there is any question, I would be glad to answer. So the question is, the resistance break is against both the virus, TYLCV and TOCV. So for the host resistance, what we have, all the commercial variety, they are having intermediate resistance against only one, TYLCV, whitefly transmitted TYLCV. So far, there is no host resistance present or identified against TOCV. So all the commercial lines and all the breeding approach that we have in Florida or in North Carolina or other places are all targeted for TYLCV, that is more prominent. So all studies are going for that. But the presence of new virus is potentially helping overcome the host resistance. So two viruses are playing together to take down the host resistance. So further breeding approach will be needed against TOCV and how we can bring in both the resistance against in a same single plant. So that will be the further how a breeder or we can work together and how we can go forward with this one. For viruses, the major management is breeding approach. There is nothing we can do at this point for virus. We can just manage the vector. And if we can manage the vector, even if a single whitefly is there that is carrying the virus, it can spread or it can introduce the disease. Any further question? Yeah, please go ahead. That's a good question. The question is if a single whitefly is carrying single virus or the single whitefly is carrying multiple virus. So based on this one, we have not studied that particular one on tomato, but on cucurbits, single whitefly is carrying at least 2 to 3 different viruses. So I presume here also it will be the same. So at this time we are studying single virus. Next we have to go for the combination of both the viruses. That study need to be done. Thank you.
Anything else for Dr. Steve? All right, we'll let Dr. Ted McAvoy come up, give us a quick update on variety and issues he's seeing there.
Thank you, Ty. So this is a solanaceous update, and what I've been working on is pepper. I'm going to talk about the variety trials that I've been doing in Phytophthora, as well as the bacterial leaf spot variety trials, and then some spacing work I've been doing with bell pepper. So bell pepper is our most important solanaceous crop in Georgia, and the most important soil-borne disease is Phytophthora, which causes wilting, and it's a water mold, and it's typically associated with the wet areas in the field. So there's been resistant varieties for a long time, but they've been developed for the Northeast region in New Jersey in particular, where they've been reusing the land over and over and over again, and they've developed problems. Well, now we are developing problems in Georgia, in part due to crop rotations that are also host, all the solanaceous and cucurbits. And compared to Florida, for example, we have heavier soils, more slope where we have low-lying areas, as well as that we don't fumigate every crop because of our restrictions on the price we could receive. We're not producing in the middle of the winter, so we reuse the plastic. So here's what we see, this is the wilting symptoms, and this is my trial. So starting off, these are the entries for the Phytophthora variety trial. Like I said, most have been around for a while, which is Paladin, and I've kind of grouped them by just Phytophthora capsicii by itself. Different levels of bacteria. What we need in Georgia is complete bacteria race 1 through 10. So these have PCAP, but incomplete bacteria packages. Then we have some newer varieties that have Phytophthora and bacteria. And then we also have some that have spotted wilt virus that Sudeep was talking about. That also goes to tomato, and it's a problem for us here in the spring. It's transmitted by thrips. So all these varieties were done at 4 locations over 2 years in Colquitt, Lowndes, and Eccles, the major production areas on growers' fields, in areas that should have had or had Phytophthora problems in the past. We compared to varieties that were susceptible to PCAP, antebellum, which is commonly grown, bacteria and tomato spotted wilt virus resistant, and Aristotle, which is old standby with no Phytophthora resistance, even though it's pretty tolerant. So this is what we found. I've highlighted with the stars the ones that I'm going to recommend. This is all the data combined from all 4 locations across 2 years averaged. We did 2 harvests. So starting out with Revolution, lots of jumbo. So for a fresh market, that's not necessarily a good thing, but I think, I'd rather skew on the side of too big than too small, and I think especially for price-listing customers, Subway, Pizza Hut, things like that, Revolution's a good option. The 1819, so here these weren't significant, but I highlighted the highest numbers, and then these ones that I highlighted, the greener, the highest, the yellows in the middle, and the red's the lowest. So for 1819, it had a high mixture of jumbo and extra large, and this extra large and large are the real money makers. Paladin, it had a good mixture of extra large and large, and in Mercer, again, good mixture and high total yields. I need to mention that in these trials, we did not have significant Phytophthora incidents. So this is mainly testing the adaptability of these varieties for Georgia. As I mentioned, they were developed for the Northeast, and a lot of them pancake, silver, and have various other problems here. So here's a picture of the ones I highlighted, going from big to small: Revolution, 1819, Paladin, and Mercer. I'll go back here. So we've done this for 2 years, 4 locations, like I mentioned, in the spring. I think the next step is to bring them in the fall. As we know, Paladin is a kind of a standard for, the gold standard for Phytophthora resistance, but it can have problems where you can see the shape, it could get pointy or silvering. Now, we did not see that significantly in the spring, and I would recommend these varieties, but in the fall, we want to see if we're getting pointy fruit or pancaking, as we may typically see, and we may get more disease as well. Going to the bacteria, so there's a different set of material. I had the same checks, but now I'm looking at varieties that are resistant to bacterial leaf spot race 1 through 10, which is our predominant foliar disease here in Georgia and pepper due to our warm, humid climate. So I tested one variety that had complete bacteria resistance, varieties that had bacteria and tomato spotted wilt, and this is typically what the growers are growing, especially in the spring where tomato spotted wilt is a problem. Again, we have the same varieties that have combinations of bacteria and Phytophthora and bacteria, Phytophthora, and tomato spotted wilt. And then we have our old standby Aristotle, our historical standard. So this is, again, the combination of everything combined. And this may not be a surprise to people because people are growing some of these varieties. This is what we are growing, so I think these are good results. Autry across the board looked excellent for all the fruit size categories. Here, mediums is better to have less because they're too small, but not significantly different than antebellum in any category. Standout. That was a surprise for me. No one's growing it. It may have a potential, if might want to try that one again across the board. Look good. And then the 3255 doesn't have spotted wilt, but again, just numerically had one of the higher yields, has good large. I might be cautious about it being small, but if you had like a Walmart or somebody that wants 55 count, the 3255 may be your best option. So here, I have my standard antebellum, and that shape really resists pancaking. But then these are my picks on our trials, from biggest to smallest. So then lastly, what I'm going to present is spacing. And so I've been doing spacing. It's my graduate student, Haley Milner's project. She wanted to do precision ag, so we tried doing variable rate spacing as they're doing in cotton and other agronomic crops. This idea was brought to me when I first started, when I visited Eccles County, and they wanted to have smaller beds, closer row spacing, like a strawberry bed where you could have more rows per acre, more plants per acre, more pepper per acre. Well, I looked into it. It looked like I needed to get a different tractor with different wheel space, different plastic layer, and all this. So what I've done is simply put more rows per bed top. So I'm on the same bed width, same tractor width, in my case, 6-foot centers, but instead of putting 2 rows on the bed top, I'm putting 3. The only difference with the 3-row, so this is easily adapted to your operation using the same equipment, is I put 2 drip tapes so that everything's getting watered and you're not planting on top of your tape with that center 3rd row. So I have 2 versus 3 rows here, and then I also manipulated the spacing between plants within the row. These are our typical plant population per acre, and this is your typical in-row spacing. But you can see I went 2-inch increments all the way out to 18, and you can see, went pretty high on the plant populations. So it's just a picture of the standard 2-row on the bed top, with just different spacing. You can see tighter spacing here and further spacing between plants. This is the 3-row, just put a center, as I mentioned, just added an extra drip tape. We had them on separate irrigation, so the one with 2 drip tapes was getting half the time of water and same amount of water because it had 2 tapes. We also strung the same. We weren't sure, with the middle row lodge or anything, we were able to pick it as well. So we want to make sure that, hey, do you have to change your stringing or picking? We did everything the same. And what we found, we didn't find a combination, but what we found was that 3 rows did better than 2 rows. Large count, more in a 3-row versus a 2-row. Jumbo count, total count. And this is count, this is weight. Found the same thing. Large, more in 3-row versus 2-row. Jumbo, more in 3-row versus 2-row, and total. I did the same presentation last week, and somebody mentioned, okay, should I keep my in-row spacing the same? My statistics didn't tell me the answer, and I want to do regression on that. But I just did a simple line graph with total yields. And as you can see, the total count higher in 3 versus 2, the marketable higher in 3 versus 2. But just based on this graph, I'm going to say 14 is, the highest one. But we're going to repeat this, and we're going to fit the proper curve, whether it's a bell curve or line graph, linear regression.
Go back to that slide.
Oh, sure.
Okay. So are you saying that, your highest yields are,
Yeah, 3-row with 14-inch between plants.
and how about 2-row? 14 again.
So that's like I said, the statistics just said 3 versus 2. It didn't say the combination. But I wanted to have an answer as an extension to say, well, I don't know. So I think that's what I'm pointing at is start off slow. I would be hesitant to tell somebody to go 3-row 10 inches. You might be pushing it. So that's where I'm starting out at is, do a moderate spacing between plants if you're going to try to 3-row. So lastly, I'd I'd like to thank everybody on this list. I'd like to thank the Georgia pepper growers that allowed me the space on their fields to do these trials. I'd like to thank the extension agents in the counties, Ty Torrance and Colquitt, Justin Shealy and Eccles, and Josh Dawson in Lowndes. I'd also like to thank the Georgia Commodity Commission for Vegetables. They did 2 years of funding for both the Phytophthora and the bacteria work, so I really appreciate that. And then I also want to, thank my graduate student whose spacing project I showed today, and everyone that helped pick as well. Any questions? Oh.
Did you look at any of the economics of how much more you had to pay for the plant? So, did the yield bear that out?
We have not done that yet, but this is a pepper talk, I kind of just stuck to pepper. But with the spacing, we're doing the same thing on onion and sweet corn, where we're doing more rows per bed top. And in every case, we're finding more rows, more yield. So with sweet corn, I'm doing the same thing where 2 versus 3 rows between the wheels. Typically with sweet corn, you've had a 6-foot or 5-foot tractor wheel, and then on 6-foot, you've had half that, 36-inch rows. On 5-foot, you've had half that, 2.5-foot rows. And we're sticking a third one in there and then skipping where you would drive, because if you were on steady 3-foot, you would be planting in your tractor wheel. So in every case, we've been finding increased yields. With the 8 rows on onions, we're finding increased yields. And that is the next step, that we want to get the economists see the plant cost, the labor cost, and if the increase in yield will be offset by your increase in production costs. We were putting the same fertilizer, doing the same sprays, so I think it would be mainly plant seeds, seeds and direct, and then, labor and transplanting costs as well.
So you have a 6-foot center, so your third bed top is 36 inches.
In sweet corn, yes. The pepper, we were, the bed top, I think it's 30-inch bed top.
30-inch bed top,
I believe so.
still your 6-foot center.
6-foot center, yes.
So on your double row pepper, 1 drip line?
No, yeah, in the double row, yeah, so Georgia,
How did you manage the study so that water might not be a barrier?
well, so I put separate timers and I put separate lines. So with the one, for example, I do 30-minute irrigation with 1 tape, and with 2, I did 15 minutes irrigation. But I had twice as many emitters, half the amount of time. I put out the same amount of water.
So the only possibility could be is you could be limiting water on one or the other to by just assuming they need the same.
And I struggled, this is true. I thought, okay, put it all on the same, but if I had tied them together, fertilizing, one would have got twice as much fertilizer, twice as much water, right? So
So your basic assumption is from the standpoint of fertility and moisture,
I tried to keep them the same, yeah.
Did you see any problem with disease with the density?
No, I did not. I didn't see any disease in the trial, but that is a consideration of airflow and moisture and all that.
Did you stake and string the center row or rely on 2 outside rows to hold?
Just staked and strung the outside, just normally. Yes, sir. I mean, it was a little bit more difficult to pick just reaching to the center row, but I mean, we could do it, so I think other people could do it.
Anything else for Ted?
Thank you.
All right, that concludes this session, but we do have other educational sessions, so try to catch one of those or visit the trade show. Thank you.